Alright, so today we're actually going to start on graphs of sine and cosine. So if you remember last time, we went over the unit circle, which is a quick one. I actually uploaded a copy of it to Canvas, but just kind of a reminder. Okay, so remember you have your square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. Then it goes back the other way for y. Okay. And then we figured out how to get all the other points, which really are just different variations of square root of 3 over 2 and the same thing, but in different quadrants. Okay. But what we're going to do here is we're going to take it from the unit circle and actually graph it on the xy axis. Like I said, I scanned it and uploaded a copy to Canvas if you want to print one up. Okay, and we're just going to do it for sine because these are kind of lengthy, so you don't have to write it for all of them. Okay, so let's say if we have our graph here, so let's say these are our theta values. And this is our sine of theta. A little uneven. Okay, so we know that if theta equals 0 degrees, which is the same as 0 radians, that sine of 0 is equal to 0. Because remember, your y is equal to sine of theta. Okay, so actually let me take a quick... Okay, so you have 0 degrees, so your y value is 0. When you go to pi over 6, your y value is 1/2. When you go to pi over 4, it's square root of 2 over 2. When you go to pi over 3, it's square root of 3 over 2. When you go to pi over 2, your y value is 1. And then if you notice, your y value goes to negative 1/2, negative square root of 2 over 2, negative, oh, wrong side. Square root of 3 over 2, square root of 2 over 2, 1/2. Then your y value is 0, then negative 1/2, negative. So you kind of see all the way around where your y value is going as your, I guess you could say, your radian value changes. Okay. So we're going to just get those and line them all up. Okay, so at pi over 6, which is 30 degrees, it's equal to 1/2, or 0.5. Okay, so we know at theta equals pi over 4, which is 45 degrees, is equal to square root of 2 over 2, which if you plug that into your calculator would give you, let me clean that equal sign up a little bit, 0.70711, and it keeps on going and going and going. Okay, so what if we plug in our pi over 3, which is 60 degrees? That would be our square root of 3 over 2, which equals 0.86603, ... and it keeps on going. Okay, so if we plug in our pi over 2, which is 90 degrees, remember our y value is equal to 1. Okay, so what if we go to 2 pi over 3, which is 120 degrees? It actually starts going back down to square root of 3 over 2, which is 0.86603. Then if you go to 3 pi over 4, which is 135 degrees, that's actually square root of 2 over 2, which is 0.70711. If you go to 5 pi over 6, which is 150 degrees, is actually equal to 1/2, which is 0.5. And if you go all the way to pi, which is 180 degrees, you know your y value is equal to 0. Okay, so now we're going to keep going around the unit circle. Okay, so let's say if you go to 7 pi over 6, which is 210 degrees, that's equal to negative 1/2, which is negative 0.5. If you go to 5 pi over 4, which is 225 degrees, that's negative square root of 2 over 2, which is negative 0.70711. Okay, so if you go to 4 pi over 3, that's 240 degrees. That's negative square root of 3 over 2, which is negative 0.86603. And if you go to 3 pi over 2, which is 270 degrees, that's going to equal negative 1. Okay, so if you go to 5 pi over 3, which is 300 degrees, that's going to equal negative square root of 3 over 2, which is negative 0.86603. If you go to 7 pi over 4, which is 315 degrees, that's going to equal negative square root of 2 over 2, which is negative 0.70711. If you go to 11 pi over 6, oh, bring that up some, run out of room. That's 330 degrees. That's negative 1/2, which is negative 0.5 or 0.5. And if you go to 2 pi, which is a complete circle, or 360 degrees, your y value is 0. So all we did was take all the unit circle theta values and find decimal numbers for them. Now you don't have to remember these, so don't worry. I won't be asking you to memorize these. This is just kind of showing the transition from one form to another. All right, so now we're going to get all these points and we're just going to graph them on a regular XY axis. Okay, so if we got all of those points, and let's say instead of sine of theta, we made it sine of x. Let's say if we decide to get those, so here, let's say this is our pi over 2, our pi, our 3 pi over 2, and our 2 pi. Okay, and this is our x-axis and this is our y-axis. All right, so we know just from our list that you pretty much go from 0 to 1. So between 0 and 2 pi, you go from 0 to 1. From 2 pi to pi, you go back down to 0. From pi to 3 pi over 2, you go to negative 1. And from 3 pi over 2 to 2 pi, you go back to 0. Okay, so we can go ahead and put that on the graph. Bless you. Ooh, bless you. Okay, so you start at 0, you go up to 1, when you get to pi over 2. When you go to pi, you go back down to 0. Then you go to -1 for 3 pi over 2. And then you go back up to 0 for 2 pi. So all the other values really just kind of go in between there. Trying to make sure I draw this connecting where it's supposed to connect. Okay, so that's actually the the graph of sine. You put it on the XY axis. Okay. Now we're not going to fill out the entire list for cosine because it's just as long and just as boring. So we're going to go right to the graph. Now, considering cosine and sine kind of interchange the whole square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, they're pretty similar in shape. The only difference is sine starts at 0 and kind of goes between -1 and 1. Cosine of x, move that up. Okay, so let's say this is your pi over 2, your pi, your 3 pi over 2, and make that just a smidgen longer. And your 2 pi. Okay, the only difference is sine starts at 0, cosine starts at 1. Okay, and when you go to pi over 2, your cosine is 0. When you go to pi, your cosine is -1. When you go to 3 pi over 2, your cosine is 0. And when you go to 2 pi, uh-oh, that's a little bit high, your cosine is 1. And it just repeats over and over again and keeps going. Okay, so you have the graph here that goes like that, and then it kind of picks up, and it goes here, and it goes like that, and it kind of repeats over and over and over again, even going in the same direction. Okay, so you have a graph here that goes like that. You have this graph that goes the same shape, but at 0, it starts at 1. All right, any questions on that so far? All right. Okay, so we have the graph of sine and cosine. Okay, so let's look at the graph of tangent. So we know that tangent of x is just sine of x divided by cosine of x. So we know that the denominator can never equal 0, so that just means that cosine of x can't equal 0. All right, so if we take a quick glance of our graph here, and move that over a little bit. You have your x, you have your y. Okay, cosine of x is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, etc., and it keeps on going like that. So we know that x can't equal either positive or negative pi over 2, because even if you're going the other way, it's still the same thing. Positive or negative 3 pi over 2. And if you keep circling the unit circle, it can equal positive or negative 5 pi over 2, 7 pi over 2, 9 pi over 2, etc., and it keeps on going. So it keeps on going like that forever and ever. Okay, so again, if we have our pi over 2, move that over just a bit. Our pi, our 3 pi over 2, and our 2 pi. And if we kind of do a quick outline of cosine, we know that's where cosine is equal to 0. Make that a little bit lower. There we go. Okay, so that's kind of just a dry sketch of your cosine. And that goes from 1 down to -1. And kind of bounces in between there. Okay. So we know that tangent can't have a denominator that equals 0. So that means we will have a vertical asymptote wherever cosine is equal to 0. So it even goes over to negative pi over 2. That would be a vertical asymptote too. Because cosine just keeps on going over and over again all the way to the left and all the way to the right. Okay, so we know we can't have any zeros there. So we kind of, or you can leave your cosine up if you wanted to. But I'm just going to erase it so you won't have too many things kind of bouncing around, or at least partially erase it. Okay. So if we plug in all of our values of tangent, all of our zeros, pi over 2s, 3 pi over 2s, pi over 4s, all of those, we'd end up with a graph that looks like this. That would probably be a little bit closer. Okay, so we know it can never equal pi over 2, but it gets really, really close to it. So since we have that vertical asymptote, that graph just gets really, really close, and it keeps on going up forever, and it can't equal negative pi over 2, but it can get really, really close. So it just keeps going right down forever. Let me move this over so it's a little more symmetric. Okay, so make that negative pi over 2, and that's, there we go. And it does the same thing between pi over 2 and 3 pi over 2. It can't equal 3 pi over 2, but it can get really, really close. Okay, and if you notice, when sine is equal to pi, it's 0. So you have 0, and cosine of pi is equal to 1. So you end up with 0 over 1. So tangent of pi is equal to 0. Same thing with tangent of 0. Sine of 0 is 0. Cosine of 0 is 1. So you end up right at 0 at x equals 0. And it just keeps repeating over and over and over between 3 pi over 2 and 5 pi over 2. 5 pi over 2 and 7 pi over 2. Just repeating over and over again. So this is your graph of tangent x. All right. So just like before, if you know your sine and cosine, everything else revolves around those two. All right. Oops, I'm gonna bring that down a little. All right. So any questions on this one? All right. Everyone's still writing. Okay. So now we know how our graph of sine, cosine, and tangent look. Now we're going to go with the graph of secant, cosecant, and cotangent, which really, once you know the first three, the other three are just reciprocals of it. Okay, so let's say if we go with cosecant of x. Okay, remember cosecant is just the reciprocal of sine. So cosecant of x is the reciprocal of sine of x. Okay, so let's draw our graph. And I'll start about right there. Make sure I go up enough. Okay, so we have our x and we have our y. So we know since cosecant is the reciprocal of sine, we know our denominator, once again, can never equal 0, which means sine of x can never equal 0. And I'll move that over here because I don't want this to get in the way of the graph. So I'll put that, so sine of x can never equal 0, which means x can never equal 0 plus or minus pi, positive or negative 2 pi, positive or negative 3 pi, and it keeps on going like that. Okay, because all those values will make sine equal 0. Okay, so we know if we have our sine graph, just do a quick little sketch of our sine graph. Okay, which looks something like that, between 1 and negative 1. Okay, so if that's our sine graph, we know it can never equal 0, which means you can never have a value there, there, or there, which is, this is our pi over 2, this is our pi, this is our 3 pi over 2, and that's our 2 pi. Okay, so that's our sine. Like I said, just kind of outlined it a little bit to give you an idea. So since we know it can never equal 0, all those points where sine is equal to 0 now become our vertical asymptotes. Okay, so this is a vertical asymptote, but you won't be able to see it. So, but this at x equals pi is a vertical asymptote. This is our vertical asymptote. I even go over to negative pi. So negative pi over 2. I'll make that negative pi. Because this just goes the same way like that. So it just keeps going over and over and over. Okay. Once again, this is a vertical asymptote. Okay. So we have our vertical asymptotes, and if you want, you can leave the sine little sketch up there. But I'll lightly erase it too, because I still want it there because we still need it. So I'm just going to lightly erase it so it's not as visible. Okay, so we have our sine wave. So if you want to find the reciprocal of that, between each interval, you just flip it. The same way you flip sine to get your cosecant, you flip that part of the graph. So you flip right across there. That goes all the way down. Even this portion here, you just flip it right across there. Okay, this portion here, you just flip it right across here. If you back up a little bit, so you can hopefully get a, there we go. So that's actually a graph of cosecant. It's just the sine graph flipped. Only just not in the spots where you have sine equals 0. So that's your cosecant. Of x. All right. Any questions on that one? All right. So your sine is actually the exact same thing. I mean, not sine, your secant is the same thing, but you're just doing it around your cosine. Clean that up for a little bit. All right, so let's say if we have secant of x, which we know is just equal to 1 over cosine of x, or just the reciprocal of cosine of x. So let's say if we start off with our XY axis. Here are X and we have our Y. Okay. So just like before, when cosecant, we knew that sine couldn't equal 0. Here, we know that cosine can never equal 0. Okay, so we have our cosine of X. I'll put that down here. And I'll put it up here. Probably should have made that a little lower, but we'll work around it. So cosine of X can't equal 0, which means that X can't equal, remember, cosine of X equals 0 at either positive or negative pi over 2. 3 pi, well, positive or negative 3 pi over 2. Positive or negative 5 pi over 2. And it keeps on going in that order. Okay, so if we do a quick sketch of our cosine, it looks, actually probably should have moved that over just a smidgen. Make sure we have enough room to go up to 2 pi. There we go. And it even goes the same way in the other direction. Okay, so remember this is our pi over 2. This is our pi. This is our 3 pi over 2. And we'll make this our 2 pi right at the end. Take it over a little bit more. And again, it goes to negative pi over 2 to negative pi and just repeats just in the other direction. Okay. So we know cosine can't equal 0, so all the places where cosine equals 0 becomes vertical asymptotes. Okay, so we know that secant can't equal any of those values. Move that up a little bit more. Okay, so once again, we're going to kind of leave the cosine up there because we're going to need it, just erasing it slightly so it doesn't stand out. All right, so just like cosecant is a reciprocal of sine, secant is a reciprocal of cosine. So wherever we have our sine, or our cosine rather, we just flip it. So here it flips down there. This one flips here. Uh-oh. This one flips there. Oh, bring that down to there. Draw little arrows on the end because they go up forever and ever and ever. And this one flips like that. Okay, so you end up with a downward parabola, upward parabola, downward parabola, upward parabola. It just kind of rotates over and over and over again. So that's actually your graph of secant of X. And I'll put it down. I'll put it right here. Uh-oh. Secant of X. All right. So any questions on that one?